Today we're going to talk about solving by factoring. You'll notice a lot of similarities to what we did last week. We're going to start each of these problems by factoring, looking for something that the terms have in common, factoring difference of two squares, or taking a trinomial, with or without a lead coefficient. After we factored, then we're going to set our parentheses equal to 0, and we're going to solve for the variables. So that's really the only new step in today's lesson. In number 1, the first thing you should ask yourself is, do these three terms have anything in common? Do they have a number or a variable that shows up in all three of them? The answer is no. So, since I have a lead coefficient that I can't factor out of this trinomial, I'm going to have to use it. The method I showed you last week is a method that some people call the bottoms-up method. Basically, you take that lead coefficient and you're going to use it twice. The first time you'll use it is you're going to multiply it times the last term. 15 times negative 7 is negative 105. This becomes our new number that we're going to use when factoring into the two parentheses. We'll take our variable n squared and split it between the parentheses, n times n. And now we're using this new number. What two numbers will multiply to negative 105 that will subtract and give me a positive 32? How do I know they subtract? Because when we multiply and we get a negative answer, we know that their signs are opposites. Anytime you combine two numbers that have opposite signs, you subtract them and you keep the sign of the larger one. 1 times 105, those numbers are too far apart. If I subtract them, not going to get 32. What about 2? 2 can't divide into 105. So let's try 3. 3 times 35. All right, there's my set. Which one is positive and which one's negative? Well, the larger term will always have the same sign as the middle number. So positive 35, negative 3. Now we're not done with that lead coefficient. Remember, we multiply it to get this number, but now we're going to take that lead and we divide it into each of our factors. Sometimes it'll divide evenly, but in this case it doesn't. So I want you to reduce each of these fractions. The first one will give me n plus 7/3. The next one is n minus 1/5. Now last week, I had you take the denominator and bring it in front of the variable so that you would rewrite each of these parentheses without any fractions. But today, because we are solving the problem, not just factoring it, I'm actually going to have you leave the fractions because it saves us a step. Once you've factored, the way that we solve is we take each parentheses and we set it equal to 0. Now, if you're solving for a variable, you want to get the variable completely by itself. So the best thing to do is look between the variable and the number that you want to get rid of, and look at what operation is occurring. In this case, n is being added to 7/3. So if I want to get rid of 7/3, I do the opposite operation. I'm going to subtract 7/3. Whatever you do to one side, you do the same exact thing to the other side. This gives me a final answer of n equal to negative 7/3. In this equation, n subtracts 1/5. The opposite operation would be to add 1/5 to both sides. This gives me n equals 1/5. In number 2, we'll start off with our question. Do these two terms have anything in common? They do. They both have a b. Write down what they have in common and then divide it out of each term. The parentheses will hold what is left over. When I divide b into 2b squared, I'm left with 2b. b divided into 3b leaves only the 3. Always double check your parentheses to make sure that you cannot factor any further. And in this case, I can't. Now it's time to solve. I'll take each part and set it equal to 0. b equals 0, and 2b plus 3 equals 0. This first equation is already solved. b equals 0. I'll go ahead and box that. To solve for b in the second equation, it's going to require 2 steps. Since you have something multiplied and something added, I always tell people to think about peeling an onion. You're going to do the things furthest away first, and then whatever's attached to the variable last. So I'm going to start off by subtracting 3. That gives me 2b equals negative 3. Since 2 is multiplied times b, the opposite operation would be to divide. b equals negative 3/2. In number 3, these two terms don't have anything in common. But hopefully you noticed this is the difference of 2 perfect squares. I'll go ahead and factor this into 2 parentheses, and I'm going to split my squares. K squared breaks down into k times k. 81 breaks down into 9 times 9. One of them gets a plus sign, and the other one gets a minus sign. Now that I've factored, I'm going to solve. Take each parentheses and set it equal to 0. In the first equation, I have a positive 9. I'm adding, so I will subtract 9 from both sides, and that gives me k equals negative 9. In the second equation, I'm subtracting. The opposite operation would be to add 9 to both sides. Final answer is k equals 9. Number 4. You may notice that this equation looks different than the 3 previous ones. It isn't set equal to 0, and that's actually something that's important. In order to factor, you do want to have all of your terms on the same side set equal to 0, and you do want to arrange them in quadratic form. Just a reminder, quadratic form will always have your squared term written first, then it will have your singular or linear term second, and then your constant last. So in number 4, we need to bring the 40 over to the left-hand side. You can do that by changing the sign of the number. So I will write this as x squared minus 3x minus 40 equal to 0. Now that you've rearranged it, you can factor it. These 3 terms don't have anything in common, so we'll go ahead and write down our 2 parentheses. The x squared breaks into x times x, and I am looking for 2 numbers that can multiply to a negative 40 that will subtract and give me a negative 3. Remember, they multiply to a negative number, which means they have opposite signs. That's how I know that they're going to subtract. Can you think of 2 numbers that multiply to 40 and subtract to give you 3? 5 and 8. So which one's positive and which one's negative? The 8 is larger, so it will match the middle term, negative 8 and positive 5. Now it's time to solve. Take each parentheses, set it equal to 0. X plus 5 equals 0. X minus 8 equals 0. When I solve the first one, I'm subtracting 5 from both sides. Answer is x equals negative 5. In the second equation, I will add 8 to both sides. So x equals positive 8. Number 5 also needs to be rearranged. I need to get everything on the same side of the equation. I'm going to bring the 72 over here to the left-hand side. When I move it from one side of the equal sign to the other, it will change signs. So now I have 2a squared minus 72 equal to 0. So do these two terms have anything in common? They do. They're both divisible by 2. I'm going to write down my 2, and I'll put a parenthesis that will hold what's left over. I'm left with a squared minus 36. Now, I mentioned before that just because you've done this first step doesn't mean you're done. Always check your parentheses to see if you can factor this further. Hopefully you notice that this is the difference of two perfect squares. So I'm going to factor this into 2 more parentheses. This is a plus 6, a minus 6. Now it's time to solve. Take every part of the problem and set it equal to 0. You may say 2 equals 0, that doesn't make any sense. And you're right. Anytime you have just a number equal to 0, we're going to throw this part of the problem out. A plus 6 equals 0, so a equals negative 6. A minus 6 equals 0, so a equals positive 6. Number 6. This is the first time that we've had a negative sign in front of our lead term, the a squared. So here's something you need to know. Your first term cannot be negative and you factor it. You just can't do it. So you have 2 options, and I'm going to show you both options using number 6 and number 7. The first option is to intentionally move this negative a squared to the other side because I know that will change its sign. It's okay to have 0 equal to your equation, to write things in a reverse order. When I bring the negative a squared to the right side, it does become positive a squared, and the rest of this remains the same. But notice, before I write this down, I want to make sure that I am writing them in quadratic form. The squared term will be first, then I'm going to write negative 3a because that's my linear term, and then I'll write negative 28 because that's my constant. Now I can factor it into 2 parentheses. A squared breaks down into a times a, and I need to think of 2 numbers that can multiply to a negative 28 that subtract to give me negative 3. 4 and 7. The 7 will be the negative because it's the larger term and it matches the middle sign. Now that you've factored, let's solve. Each parentheses will be set equal to 0. In the first equation, I'm going to subtract 4. So a is equal to negative 4. And in the second equation, I will add 7. So a is equal to 7. In these last 2 examples, we're not going to be able to factor out a common term, and we are going to be left with a lead coefficient. In number 7, this lead coefficient also happens to be negative. So I do have the option of moving every term to the other side, which would just change every sign, but I wanted to show you one more option. You can divide out a negative 1. That would accomplish the same goal. When I take negative 1 and divide it into every term, it will change the sign. Positive 4x squared, negative 4x, negative 3. I still need to factor this trinomial. I'm going to factor it into 2 parentheses. Since I have a lead coefficient, I will multiply my lead term times my last term, and that gives me negative 12. I need to think of two numbers that can multiply to negative 12 that will subtract and give me 4. 2 and 6. It's going to be a negative 6 and a positive 2. Now don't forget, since you have this lead coefficient and you had to multiply, you also need to divide both of your factors by that lead term. If it divides evenly, do that, but if it doesn't, you need to reduce. So I've got negative 1 times x plus 1/2 times minus 3/2. Now we're going to set each parentheses equal to 0. Remember, since I just have a number out front, I don't have to write negative 1 equals 0 because that doesn't make any sense. So we'll throw that out. X plus 1/2 equals 0, so x is equal to negative 1/2. X minus 3/2 equals 0, so x is equal to positive 3/2. Number 8. Do these three terms have anything in common? No. So I do have this lead coefficient. I'll multiply my lead times my last, and I get a 4. I need to think of two numbers that can multiply to 4 that will add and give me a negative 5. When they multiply to a positive number, they have the same sign. Negative 1 times negative 4 will give me positive 4. Negative 1 plus negative 4 gives me a negative 5. Don't forget, since you had a lead term, you have to divide each of your factors by that lead number. If it divides evenly, that's great. If it doesn't, just reduce it. This first one will remain x minus 1/2. The second parentheses will become x minus 2. Take each parentheses and set it equal to 0. When you solve the first equation, you'll add 1/2 to both sides, so x is equal to a positive 1/2. In the second equation, you will add 2 to both sides, so x is equal to 2.